you're going to add something to a trinomial to make it a square for a purpose. Okay? But we'll get there. Example 1. What?
Can you multiply square root instead of adding?
You're not going to multiply. All we're going to do is we're going to add stuff to make it a square. We're not going to multiply to make it a square. So up here, solve this equation. What are some ways you would think to do right? What are some steps you would take right now? Okay, one thing I told you to do, make it equal to 0. But actually, we're not going to go that route this time. There are so many ways to approach quadratics. Maybe that's why people get confused. But only had a couple, actually, so far. In this case right here, we don't make it equal to 0. It actually could. You could. And it would actually work out in this case. But that's not our route. Look at the left-hand side. What do you notice about this right here?
Oh, you can factor it.
You can factor it. Go ahead and factor the left-hand side. Go ahead. You with me? Okay. You're going to see the importance of this real quick. If you factored the left-hand side the way it is right now, instead of moving 25, what do you notice about the left-hand side? It's a perfect square. It's a perfect square. The left-hand side. So you have to write it as a perfect square. What is it? So this is x minus 4, but don't write it out twice. Do this. X minus 4 squared equals 25. Do you know why we do this? You know why it's easy now? Do what to both sides? Square root both sides. Yeah. Right. So you square root. We made it a square. Actually, it already was a square. It already a square so that we can square root. If we square root this side, we'll get x minus 4. If we square root this side, 5.
Plus 4.
Don't forget that plus minus. Don't forget that plus minus. We're square rooting x squared plus or minus.
You get x by itself right now.
What do you think? Yeah, we want to solve. We're always trying to get x by itself when we solve. So, yeah, always 2 answers for x squared. So, plus 4, we get x equals 4 plus or minus 5. Now, if you write that as your answer, I'll take off a point. Why? You can do it, right? You can do it. 4 plus 5, 9. 4 minus 5, -1. Put them in nice brackets, please. All right, 9 and -1. If you put 9 up here, it would work out. Put -1 up here, it would work out. Okay, so example type number 1. Look to see, actually the very first thing I do, I look to see, is this a square right now? Is that a square? Now what if this side factored into, let's just kind of think hypothetically here. What if this side factored into like x plus 4, x minus 3 equals 25? What would you do with that?
I'll FOIL it. That equals 25, that equals 25. No?
That's a common mistake.
Wait, no.
It is. The only time you can do that, Sam, if it was equal to 0. You can never say this equals 25. You would think logically it might work out, but it actually doesn't work out.
Can you subtract it by 25 and use FOIL and then you
In this case, you would have to, yeah, minus 25, put it over here, FOIL it out, kind of make it, something equals 0. So you wouldn't want to say this equals 25, this equals 25. So in this case, I wouldn't factor it out. I would just subtract 25, put it over here, and then try to solve from there. Okay? You see the different situations you're going to come across. Okay? This situation, I'm looking. Is this a square? Yes, it's x minus 4 squared. Perfect. Why is it perfect to have a square? So that you can square root it. That's why you want squares. So you can square root it to get your answer. That's what we did. Okay, so that's the first thing you want to look for. If it's a perfect square. Next question. What if it's not a perfect square? Like this. Question number 2. Find the value of C that makes that a perfect square. So question number 1, it already was a square. This question, you're making it. That's the whole point of this whole section. You're making square.